Hi guys, this is experimental chemistry and we are looking at apparatus commonly found in a chemistry lab and their uses. Measuring cylinder. Measuring cylinders are pieces of apparatus found in the chemistry lab used to measure volumes of liquids which are approximate. Now, approximate volumes mean that the exact volume is not required. In fact, a volume very close to the volume written in the experiment is needed. For example, if we are supposed to take 50 cm cube of an acid and it says that 50 cm cube of acid which is in excess, that means that the quantity 50 cm cube is already in excess. That means if the volume is slightly lower or higher than 50 cm cube, it would not hinder the experiment at all. So a measuring cylinder is used for such volumes. Where accuracy is needed, then we would use a pipette or a burette. So, in order to measure approximate volumes, and these volumes are variable because measuring cylinder has graduations on them of 1 cm cube for a 50 cm cube capacity of a measuring cylinder. So, in the close-up view, as we can see that the volume that has been taken is, if we consider 40, 41, 42, 43. The lower meniscus is set at 43 centimeter cube. So the volume that is being taken in this measuring cylinder is 43 cm cube, which is an approximate value, not an accurate value. The reason being that the least count on the measuring cylinder, which measures to 50 cm cube, is 1 cm cube, which makes its error as half of least count, which is half of 1, which would be 0.5 cm cube. And measuring cylinders are usually used to measure a single volume or take a single reading, so the error stays 0.5 cm cube. So if we took 43 cm cube here, for example, we would have a percentage error of 0.5, which is the error in using this measuring cylinder, divided by 43, which is the volume taken, and multiplied by 100 would give us a percentage error of 1.16%. If we take the maximum volume that is available to us, that is 50 cm cube, so the percentage error for measuring 50 cm cube volume would be 0.5 upon 50 into 100, which gives us 1.00% error. Now, this percentage error is much higher than the percentage error we obtain when we measure the same volume using a burette or a pipette, because those pieces of apparatus have been designed for accurate measurement. So, accuracy is of key importance in those devices. So we only use them when the accurate volume needs to be measured. So, and the reason the measuring cylinder does not measure accurately and only approximately is because it has got a much wider diameter as compared to a pipette or a burette. A beaker is a piece of apparatus found in a chemistry lab that is usually used to contain liquids. It is not used to measure any volume. The graduations on a beaker is there just to suggest how much liquid is present inside the beaker. They have got a very wide diameter and are only used as containers. So solution containers, not used for measuring volumes. So if we have a beaker that says 300 cm cube or 500 cm cube, as shown in the diagram, This is there just to suggest that this is the volume that the beaker can contain. So if I fill up the beaker up till 400 cm cube, for example, so that is giving me an idea that almost 400 cm cube of the solution is present in the beaker. We cannot use this volume measured using a beaker anywhere, because this is not even as accurate as the volumes measured using a measuring cylinder, which is a piece of apparatus used for measuring approximate volume. So, in conclusion, we can say that a beaker is only a solution container that gives us an idea of how much liquid is present inside it. The volumes mentioned on the beaker are not accurate at all. A conical flask is a piece of equipment in the lab that is used to contain liquids that will be used during a titration. So we take the liquid out using a pipette and a pipette filler, which would measure accurate volumes of a solution, and then we empty that pipette inside a conical flask. So the conical flask is also a container with measurements written on it. The most commonly used conical flasks have a volume of 100 and 250 cm cube. However, conical flasks with larger and smaller volumes are also available in the labs, and they are used during the titration by placing the liquid from the pipette into the conical flask, then adding the indicator, and then titrating the solution in the conical flask with the solution from a burette to reach the end point of a titration. So a conical flask is a container for solutions taken using a pipette and in some cases a burette to be used during titrations. Conical flasks have other uses as well. For example, if we need to perform an experiment in which we need to determine the rate of production of a substance, so we place a solution inside the conical flask and we place the conical flask over an X, a paper with an X on it. The conical flask will have the solution placed in it, and another solution will be placed in the conical or added to the conical flask from another container, and this solution, when added, will start the reaction inside the conical flask, and we use a stopwatch to time the experiment, and soon enough we would see that the liquid inside the conical flask will begin to haze up, and eventually we will no longer be able to view the drawn X on the paper through the solution inside the conical flask, and that would be the time at which we stop the stopwatch, and in this way we would obtain the time taken for the X to disappear. And this is used in rate experiments or reaction kinetics experiments. So this is another use for a conical flask. Volumetric flasks are also known as graduated flasks, and their purpose in a chemistry lab is for preparation of dilute solutions. So the volumes available for the volumetric flask are variable, starting from 50, 100, 250, 500, and 1 dm cube or 1000 cm cube. These are the common ones found in the lab. So the graduated flask or volumetric flasks are used in such a way that we either use a pipette or a burette to draw a solution from another container and empty that inside the conical flask. We empty the pipette, but we take a certain volume using a burette. Then we use distilled water using a beaker and a funnel and make up the volume of the conical flask, not the conical flask, volumetric flask, up to the mark as seen in the diagram. The lower meniscus would be at the mark if the solution is transparent or clear, and the upper meniscus would be at this mark when the solution is colored. So when we fill it up with distilled water, then we put the stopper back on the top of the volumetric flask. The stopper can be seen here. And the next thing we do is we would invert the conical flask to mix the solution with the distilled water. So when we invert it, the air present between the mark and the stopper is what passes through the solution, and it is what is used to mix the solution to form a uniformly dilute solution. So this will be done several times so that the air bubbles properly mix the solution present with the water in order to dilute it. And as a result, the volumetric flask, if used properly, will be able to prepare a known dilute solution of a given acid or a base or any other liquid that we need to dilute.